Alright guys, so we're going to start a couple videos here going over the review. I know most of us haven't finished it in class yet, so if you're seeing this now over the weekend, go through all of them. You can get a little bit ahead. Alright, so number one, which angles form vertical angles? The letters here are determined to be points, right? W, X, Y. So we're just really looking at the angles with numbers, even though there are more pairs of vertical angles. So the obvious answer here would be angles 2 and angle 3. Okay, those are vertical angles there, not including that 5. But when two lines intersect, the angles formed are called vertical. They're also congruent with each other, something to keep in mind. Number 2, every teacher at John Jay is female. Provide a counterexample to the previous statement. Okay, very simple counterexample. Don't think about if-then statements here. You do not have to rewrite this as if every teacher is at John Jay, then they are female. This is literally just give an example that would make the statement not always true. So the obvious one for our class would be, the obvious one for our class would be me, right? Mr. Rodriguez is male. Okay, you can name any male teacher here. Sorry, pen's going a little crazy. You know, Mr. Frias, Mr. Ford, Mr. Katera, Mr. Falkenberg, any male teacher obviously would work. Number 3, the midpoint of AB is M, and the coordinates of M are 1, 4, and the coordinates of B are 5, 1. What are the coordinates of A? So, two ways to look at this problem. The formula for midpoint looks like this. And that's going to give you a point. But the problem with this problem is that we have the midpoint value. We do not have one of the two endpoints. So, two ways to do this. I think this is the easiest way. If you want to use the formula, you're going to have to do some algebra. But I think this is a little bit easier. Okay, you have A, B. Here's your midpoint. We know B is at 5, 1. We know M, the midpoint, is at 1, 4. What we do not know is what point A is. Okay, that's unknown at the moment. Now, a midpoint is in the very middle. It's the same distance from one point as it is to the other. So if that's true, we start at the x-coordinate of the M of the midpoint. And to go from 1 to 5, you had to go plus 4. Okay? Well, if you go plus 4 in one direction, you must go minus 4 in the other because it's in the middle. So minus 4. 1 minus 4 is a negative 3. Okay? So that's the x-coordinate of A. Now, do the same thing for the y's. All right? 4 to 1. 4 to 1, you had to subtract 3. But to get to the other y, then you would have to add 3. 4 plus 3, 7. 3, 7 is the point A. Okay? If you want to use the formula, you'll have that there on the day of the test, but you'll have to do a little bit of algebra for that. Moving on, number 4, are these lines parallel, perpendicular, or oblique? So in order to determine if it's any one of those, we have to compare slopes. Now, normally we would have to do some algebra here, get these to y equals mx plus b form, and that requires 2 steps of algebra per equation. But there is a little bit of a shortcut, and we covered it in some classes, not all of them. So if you didn't see this, I'll try and go back over it when we get back on Monday. But for slope, if you have a standard form equation, which is this, the ax plus by equals c, your slope can be found as negative a over b. You may have some notes on a pink page in your notebook from earlier in the year that just had a over b. There was a typo. I think we covered that, but some people said we didn't. So basically what you can do, if we call this equation 1 and this equation 2, for equation 1, the slope is going to be negative 9 over negative 7. Negative a makes that negative 9. And b is negative 7 because that negative is already there with it. Now, that's going to cancel both of them out. You get positive 9 over 7. For equation 2, you have negative 7 over 9. Okay? So now you're comparing the two. If they're parallel, those would be the same fraction. They would be equal. Obviously, they are not. So if they were perpendicular, then they would be what we call opposite reciprocals, meaning one has a positive sign, one has a negative sign. Notice that's positive, that's negative. The other part is the number is flipped. Here we have 9 on top, 7 on the bottom. Here we have 7 on top, 9 on the bottom. Those are what we call opposite reciprocals. These are perpendicular. If neither of those two things occur, if they're not the same or they're not opposite reciprocals, then you would have chose oblique. That's the third choice, basically meaning neither. Number 5, write an equation perpendicular to the line graph below. So in order to write equations, there are two things you need. Now, most of y'all always get the first part, it's slope. A lot of times y'all say slope and y-intercept. But really it's just slope and a point. Okay? The y-intercept is a point, and if you have it, it makes you, it allows you to get y equals mx plus b easier. But even if you don't, it's okay, because a point can still get you an equation through the point-slope form. Point-slope form is y minus y sub 1 equals m times x minus x sub 1. Now, this is write an equation perpendicular. Okay? This slope right here goes down 1 over 4. 1, 2, 3, 4. So AB right now has a slope of negative 1/4. But we need to be perpendicular to that. Like we said on the previous problem, perpendicular, you flip the numbers, change the sign. Negative becomes positive, numbers flip. The slope I need to use is 4. The point on the picture there, they give us P. We'll go ahead and use that. That's negative 1, 0. So, M is the slope. The point gives us x1 and y1. The x and y's that are by themselves there are going to stay x and y. They're not going to change into numbers. Okay? And then this becomes y minus. Now, y1 is 0. We don't really need to write it. I'm just putting it there so you understand where it comes from. But you could just leave that y equals at that point. M is the slope 4 times x minus x sub 1, negative 1. Right here in the parentheses, minus negative becomes positive. So when we rewrite this, it's y equals 4 times x plus 1. You have to distribute y equals 4x plus 4. And that is your perpendicular equation. Number 6 is simply a vocabulary term. A line that is perpendicular to a segment and contains a segment's midpoint is called the perpendicular bisector. Okay, so perpendicular right there in the question or what they're asking, and then bisector means to cut in half. So if you cut in half at 90 degrees, and of course if you're in half, you're at the midpoint. Okay. For number 7 here, there are lots of examples for A, B, and C, so many that I'm not sure I can really go over all of them. So I'm just going to kind of go over for each one what they're looking for. Supplementary angles. In the parallel line and transversals that you have here, supplementary angles generally come from 3 things. Okay. Now, the first one is not really associated with what we're trying to look for, but they're there all the time. And those would be linear pairs, like 1 and 5. Or 3 and 4. 2 angles that are adjacent right next to each other and form a straight line, right? And those are all over here. Really take any 2 angles next to each other and they form supplementary angles. But that's really not what we're looking for in the parallel lines and transversals. The other type come from what we call consecutive interior. Angles that are right next to each other inside the 2 parallel lines. So 6 and 10 are going to add up to 180. Okay? 7 and 11. Right? And actually I shouldn't be using those curves there because that doesn't mean they're all the same. But in between any 2 parallel lines, consecutive interior. So 8 and 12. Right? Or even over here, 11 and 10. Right? So any of those are going to be considered same side or consecutive interior. The last one is one that you don't always see on the notes that we talked about, if you remember, which is same side exterior. Angles outside the two parallel lines, but on the same side of the transversal. 1 and 13. 2 and 14. Right? 3 and 15. Right? Any of those same side exteriors are going to be supplementary. Now, 4 pairs of congruent angles. Again, lots of way to get congruent angles here. The first one that they probably aren't included in this, but are, of course, the vertical angles. You know, the ones across from each other, there's just pairs in every corner across from each other, right? So 1 and 6, 2 and 5, 3 and 8, 4 and 7, 9 and 14, 13 and 10, 11, 16, 12, 15. All right, those are the obvious ones. The ones that we get from the parallel lines, corresponding angles. 1 and 9, 14 and 6. Those are what we call corresponding. They are in the same position in their group, in both of their groups. So like for instance, over here, 3 is in the top left corner of this intersection. 11's the top left corner. They correspond. They're in the same spot. Okay? Those are congruent. Same is true for 16 and 8, right? Same position of their group, right? And that works across too. 8 and 6 would also be congruent, okay? Then we also have alternate interior, all right? So alternate means on different sides of the transversals. Interior means between the two lines. So 6 and 9 here, all right? 7 and 12. But also 5 and 10, 8, 11, right? And that's between any two lines. And of course, with the two parallel lines here going both directions, it does make a little bit of it confusing. All right. The last one would be alternate exterior. So again, different sides, but outside the two lines. So 1 and 14. Okay. 3 and 16, right? Alternate exterior. So all kinds of angle combinations we have in here. You just need to try to know which ones are either equal to each other, congruent, and which ones are supplementary. Number 8 in the figure, J is parallel to K. Solve for X and find the value of every angle. So here's the one we're used to, 2 parallel lines, 1 transversal. These right here, these 2 angles, are what we call same side exterior. Now, if you said consecutive interior, I wouldn't really care, but technically consecutive means they are next to each other. So this means that they are on the same side of this transversal. They're both over here. And exterior, of course, they're outside the 2 lines. All right? Now, anything that's same side or consecutive, that is going to be supplementary. Okay, they are going to equal 180. So that's what we're going to do here. We're going to do 5x minus 20 plus 3x plus 40 equals 180. Okay, getting a little crazy with the pen there. Got to do a little bit of algebra. It's multiple choice. If you want to use and solve, I mean, you have that option, but you should know how to do these. You're going to need to know how to do them throughout the next few years. Combine your like terms, right? You get 8x minus 20 plus 40 becomes plus 20 equals 180. You know, once you're in this, it's 2 simple steps. Get rid of the number that's usually by itself. So minus 20, 160. 8x equals 160. I'll move it up here. Divide by 8, x equals 20. Now, that only took care of part of it. It did also say to find all the angles. Now remember, in the parallel lines cut by a transversal, there's only 2 angle measurements that are going to show up here. So the two angles are either congruent or supplementary. Right? So we have 5x minus 20 up here. X is 20. So you do 5 times 20 minus 20. 5 times 20 is 100. 100 minus 20 gives me 80. Okay, now this is going to be 80 because it's vertical angles. There's an example of vertical angles. This is 80 because that is corresponding like we talked about earlier. And that's 80 right there because the vertical, also you'll notice these are alternate interior here. These are alternate exterior. So there's some of those examples of what we looked at above. That makes everything else have to be supplementary and make it add up to 180. So that gets 100, 100, 100, 100. Okay, so only two angle measurements, and notice linear pairs here add up to 180. Vertical angles are congruent. Consecutive interior add up to 180. All those things we talked about, you can see those examples here. All right, question number 9. If two angles in a triangle have measures of 58 and 71, what must be the supplement of the third angle? So this is not just simply asking what is the third angle in the triangle, because that's easy. Most of y'all know you would add 58 and 71 and subtract from 180. But this wants the supplement. A supplement adds up to 180. So if you think about it, these two numbers, 58 and 71, they have to make 180 with the third number. And we're looking for the supplement of the third number. So this third number has to make 180, and we already know how to make it equal 180 because it's those two. If you're confused about what I'm saying, let's look at this, okay? Add 58 and 71, okay? You get 129, and then normally to find that third angle, we would do 180 minus 129, and that's going to give you 51. Okay, so the third angle would be 51. But like we said, they don't want the third angle, they want the supplement. What makes 180 with 51? Well, we've kind of just figured that out, right? We added those two, we subtracted that from 180. That is a supplement. This is our answer. What must the supplement of the third angle be? 51 is the third angle. Its supplement is 129. So if you understand what you're doing, you just add the numbers and you're done. If you don't, you still do these two steps and you get back there, because then if you were doing what we were doing originally, you get 51, and then you're saying, oh, I need a supplement. I need to subtract it from 180, and you take yourself right back there. Okay? Read the questions very carefully. That's important, and make sure you answer what they're asking. All right, last question on this page. List the angles from smallest to largest. Okay, remember the idea. Across from the largest angle is the longest side, and vice versa. Across from the longest side is the largest angle. All right, so in order here, if we're going to go from smallest to largest, I want to start with the shortest side, 3.6. Okay, what angle is that across from? When we say across from, right, there's three angles. These two angles connect to make the 3.6. What's the angle it doesn't touch? This one over here. That's the angle it's across from. All right, so that's angle Z is your smallest angle. All right. So now what's the next biggest side? 4.5. Okay, that connects with these two. Now what's the angle that's not touching the 4.5? That's Y. That's what you're across from. That's the middle angle. Okay, longest side now, 5.8. Okay, connected by those two. Across from that angle, of course, angle X. So Z is your smallest angle, Y is the angle in the middle, X is the largest. All right, so we're going to stop there for page 1. There'll be another video for the other pages on here. Hope these help you out. We'll see you back in class on Monday.